In today's lesson, we are going to talk about the application of quadratic relations. Just to remind you, a quadratic relation, the graph is called a parabola, and the parabola can be either opening upward or downward. It opens upward if the leading coefficient is greater than 0, or opens downward if the leading coefficient is less than 0. The other thing that we talked about are the x-intercepts or the zeros of a quadratic relation. If you plot a quadratic relation, the zeros are the points that the graph crosses the x-axis. If you take these two zeros, x-intercepts, and then find the average, the point is going to be right in the middle of these two x-intercepts, which corresponds to the x-coordinate of the maximum or minimum, which we call the vertex. And the line that goes through this point, which we call the axis of symmetry, is going to make the parabola such that the left one is the reflection of the right side, or the right side is a reflection of the left side. We also talked about how to find the vertex using the equation v sub x is equal to minus b over 2a. And to find the y-coordinate of the vertex, we said we are going to substitute this value back in our original quadratic equation to find v sub y, which is the y-coordinate of the vertex. Our first example is, consider the quadratic relation y is equal to 4x squared minus 72x plus 260. The question is that, does this relation have a maximum or minimum? Explain. We look at the leading coefficient, which is 4. Since 4 is greater than 0, a is greater than 0, this means that the parabola opens upward. So the vertex has to be a minimum value. The next question says, find the zeros of this relation. To find the zeros, we have to find the factors, or we have to solve this equation. To solve it, either we can use quadratic formula, or we can use our knowledge about factoring. I'm going to factor out 4 from these three terms. So I'm going to get 4 times x squared minus 18 plus 65. Value 65, since the leading coefficient is 1, I have to find two numbers that the product is 65 and they add up to negative 18. Those two numbers can be either 1 and 65 and 5 and 13. Look at these pairs. The only one which is going to give me the sum of negative 18 is 5 and 13. If I make both of them negative, negative 13 plus negative 5 gives me negative 18, and the product gives me a positive 65. So I can write that this one is 4 times x minus 5 times x minus 13. Now I have to make this one equal to 0 to find the zeros. This one gives me the product of three numbers, 4, x minus 5, and x minus 13. To make this equal to 0, one of these numbers has to be 0. 4 cannot be 0, so x minus 5 is 0. This gives me x is equal to 5, or x minus 13 is equal to 0, which gives me x is equal to 13. The next question says, determine the coordinate of the maximum or minimum point. We said previously that since the leading coefficient is a4, which is greater than 0, parabola opens upward, so it is a minimum point. To find the x-coordinate of the vertex, I can use two equations. The first one is v sub x is minus b over 2a, which is equal to minus negative 72 over 2 times 4, which gives me 72 over 8, which is going to be equal to 9. This is one way of doing it. Or the other way is that I find the average of the x-intercepts. I can say v sub x is 5 plus 13 divided by 2 is 18 divided by 2, which is equal to 9. You can see that it gives me exactly the same value. The next part of the question says find the maximum or minimum. I know that the x-coordinate of the vertex is 9. To find the y-coordinate, I sub it back in this equation and evaluate y. So I say v sub y is 4 times 9 squared minus 72 times 9 plus 260. If you use your calculator, this is going to be equal to negative 64. So this means the maximum or minimum. But in our case, since 4 is greater than 0, parabola opens upward. So the minimum value of this function is negative 64. The next part of the question says write the relation in vertex form. I know the vertex is 9 and negative 64, so I'm going to use the general form of a vertex, form of a quadratic, as a times x minus h squared plus k. My h is 9, my k is negative 64, and the a is 4. So I get 4 times x minus 9 squared minus 64. Now you can always expand this one and check it against the original one to see if it gives you the same equation. The next example, we have a rectangular garden with the dimensions 12 meter by 8 meter, which is surrounded by a walkway of uniform width of x. So this means that we have a rectangle like this, and then we have a walkway. Now this distance is x. This is 8 and this is 12. The total area of the garden and the walkway is 252 square meter. We are supposed to write an expression for the total length and the total width of the garden. The total width of the garden is this one, which is going to be 12 plus 1x and 2x. So it's going to be 12 plus 2x. This is going to be the total width of the garden. The total height is going to be this, which is 8 plus x, which is 8 plus 2x. The next question says, write an expression for the total area of the garden and the walkway. Remember that the width was 12 plus 2x. The height was 8 plus 2x. And we know that the shape is a rectangle. If we find the product, that's going to be the area. The next part of the question says, find the width of the walkway. We know that the total area is 252, and we know that the width is 12 plus 2x, and the height is 8 plus 2x. The product is the area. So to find the width, we have to find the value for x. So we have to solve this quadratic equation. To do that one, I'm going to expand this one. I'm going to say 12 times 8, which is going to give me 96, plus 12 times 2x gives me 24x, plus Now I'm going to multiply 2x by 8, which is 16x, plus 2x times 2x gives me 4x squared. And then I move 252 to the left, so it becomes negative 252, which is equal to 0. Now I'm going to simplify this one. I'm going to write 4x squared first. There is no like term like x squared. Then 24x plus 16x is going to give me 40x. Now I'm going to add 96 and negative 252, which is going to give me negative 156 is equal to 0. Now I have to solve this quadratic equation. Either I can use quadratic formula or I can use factoring. Let's try factoring. First, I'm going to factor 4 out. I can divide every coefficient by 4. I get 4 times x squared plus 10x minus 39 is equal to 0. I know the product of these two numbers are 0. 4 cannot be 0, so x squared plus 10x minus 39 is equal to 0. Since the leading coefficient is 1, I'm going to find two numbers using the sum and product. Find two numbers, the product is 39 and the sum is 10. Those two numbers can be either 1 and 39 or 3 and 13. Now I have, between these two pairs, I have to find one with the sum equal to 10. The best candidate is 3 and 13. Since the product is negative, one of them has to be negative and the sum has to be 10. So this means 3 has to be negative and 13 has to be positive. So the sum is 10. So I can write this equation as x minus 3 times x plus 13 is equal to 0. So this means that either x is equal to 3 or x is equal to negative 13. Since x is the width of the walkway, it cannot be negative. So this answer in the context of the problem doesn't mean anything. So the answer is x is equal to 3. So the dimensions becomes 12 plus 2 times 3, which is 12 plus 6, which is 18, and 8 plus 2 times 3, which becomes 14. In the next example, we are supposed to plot a few graphs. The first one is y is equal to 0.15x times x minus 12. You always, to plot parabolas, we always find the coordinate of the vertex first, then the x-intercepts, then the y-intercept, and then we plot the points. And then we draw a smooth curve going through those points. So the first thing is we are going to find the x-intercepts. For this equation, we know that the x-intercepts are the points that makes y equal to 0. These are the roots, so it means that the x-intercepts here are x is equal to 0 and x is equal to 12. Because if x is 0, then 0.15 times 0 times anything else is going to give me 0, and when x is equal to 12, this guy is going to be 0. So I'm going to plot x equal to 0 and x equal to 12. So it's going to be somewhere around here, outside the graph. Now I'm going to find the y-intercept. To find the y-intercept, we have to find the value of y when x is equal to 0. When x is equal to 0, then we get y equal to 0. So the y-intercept is going to be 0, which is going to be the same point at the origin. The next point that we are going to find is the coordinate of the vertex. To find that one, the easiest way to do this is to find the zeros, which is already been found, and then find the average. So I'm going to say v sub x is 0 plus 12 divided by 2, which is going to give me 6. Now to find the y coordinate of the vertex, I'm going to sub it back in the equation, and I get v sub y is 0.15 times 6 times 6 minus 12. If you simplify this one, you get this is negative 5.4. So the vertex is going to be at 6 and negative 5.4. Now I have enough information, I can go ahead and plot the points. The last point is the vertex, which is 6 and negative 5.4. So 6 and negative 5.4 is going to give me a point like this one. Now I'm going to just draw a smooth curve going through these points. So this is one, and this is another one. The next example, we have to plot y equal negative 0.2x times x minus 2. We do the same thing. We have to find the x-intercepts, y-intercept, and the vertex. The x-intercepts here are the values of x that makes y equal to 0. So the x-intercepts are 0 and 12. So this means that it's going to be the same 2 points that we had before. Now the y-intercept, we put x equal to 0, you can see that y becomes 0. So the y-intercept is going to be exactly the same thing, 0. Now to find the vertex, the coordinate of the vertex, as we did before, we are going to find the average of the two x-intercepts. So it's v sub x is going to be again 0 plus 12 divided by 2, which is going to be 6, which is the same x coordinate for the vertex previously, and the y coordinate of the vertex, we just sub it back in this equation. We get v sub y is equal to negative 0.2 times 6 minus 12. If you evaluate this one, you get 7.2. So the vertex here becomes 6 and 7.2. Now we're going to go ahead and plot the points. The only difference now is the vertex, which is 6 and 7.2, which is going to be somewhere around here. Now again, I do the same thing. I'm going to connect the points and draw a smooth curve. So it's going to be somewhere, something like this. The next equation that we have to plot is y equal negative 0.4x times x minus 12. Again, we do the same thing. We are going to find the x-intercepts. The x-intercepts for this equation again are 0 and 12. The y-intercept is going to be the same. If you put x equal to 0 here, you get 0. So the y-intercept is the same. Now the vertex, the x-coordinate is going to be the average of these 2 points, which is going to be again 6. We put it back to find the y-coordinate of the vertex. We get y, v sub y is negative 0.4 times 6 times 6 minus 12. If you evaluate this one, we are going to get 14.4. So the vertex is going to have the coordinate of v sub x result y is equal to 14.4. So when x is 6, then y is 14.4. So it's going to be somewhere around here. So this is going to be my curve. Now it says what is the same about the graph and the relationship, and what is the difference. Now if we look at the graph, you can see that all these graphs, they have the same zeros. The zeros are here and here. The difference is the vertical compression and stretch. And the reason is that if you look at the leading coefficient here, here is 0.15, which means compression vertically by a factor of 0.15. Here, it means compression by a factor of 0.2, and this one is a compression by factor of 0.4. The other thing is that the reflection. Here, we are reflecting about the x-axis, and here we are reflecting about the x-axis because a value is negative. Here, we are not reflecting at all. And also, the other difference is the coordinate of the vertex. Look at the vertex here, the vertex here, and the vertex here. Also, because of the value of a, the direction of opening is different. Here, the value of a is positive, so this means that the parabola opens upward, which is this one. And the other two cases, negative 0.2 and negative 0.4, because a is negative, the parabola opens downward, which are these two cases. Next question says, write the equation for a parabola that has the same zeros. Remember the zeros that we had they were 0 and 12. And it passes through the point 48. Remember, when the zeros are given, the best way to solve the problem is using the x-intercept form of a quadratic equation, meaning y is equal to a times x minus r times x minus s. Remember, r and s are the zeros, and the zeros in this case are 0 and 12. So I can write this one as a x minus 0 times x minus 12, which is the same as a x minus 12. Now the only problem we have is a value, but to find the a value I need another piece of information, which is this one. So when y is 8, x is 4. So 8 is equal to a times 4 minus 12. Here I get 4 minus 12 is negative 8. 4 times negative 8 is negative 32a. I divide by negative 32. I get a is equal to negative 1 over 4, which is negative 0.25. So I can say y is equal to negative 0.25 x minus 12. So this is my equation.